Okay, I think I'll start. It's the right time.
Yep, absolutely.
Okay, perfect. Do you want to mute everybody else?
Yep, all set.
Okay, perfect. So thank you, everyone. Thank you once again for joining for our third part in the series of using AI with RPA. What we wanted to do was talk about typical use cases of for using AI along with RPA in today's session. Um, so today's speaking is Vachan with me. He's our lead machine learning engineer, and I'm Ashish Nangla, and I'm the CTO here at Accelirate. Today's session using AI with RPA. So we want to talk about typical use cases and what is a good use case and what is not for RPA. This is the third webinar in the series. The first one we did on 21st April was more around introduction. The second one was about implementation of using AI and RPA. And today we are talking about the typical use cases. Okay. Again, just for a refresher, the perspective we have taken over here is essentially that we have various aspects of a business case or a business process, and there are different solutions to address as part of automation and digital for business processes. We've been always been talking about using RPA to automate user actions, and this session especially is talking about taking away decision making and some of the extraction work or and other things from AI using AI and machine learning. Okay, uh, we'll dive straight into the use cases. We've already covered the fundamentals of machine learning. What is it, and how do you use it? What are the different tools? We've already covered in the last week's series different implementation options. The business, the process, the SDLC process of how to develop AI and machine learning solutions. So we have covered all that, and I think some of the things we come down to is really feasibility now and identifying use cases. And we'll talk about 4 use cases in today's session. So before we start with the 4 use cases, we'll talk about feasibility. How do you recognize feasibility? How do you understand what is a good use case? So first thing, these are 9 items that we thought we can share today. There are more, of course, and as we and there are some further questions in each of these as well. But essentially, these are good points that you can remember to look at business processes and use cases and define feasibility for use with AI and machine learning. First is accuracy requirements. We come across tasks and workflows where things are needed pretty much 100% of the times to be accurate, and there's no variation possibility over there. Those are not good use cases where there is variation and there is possibility that you may not get an optimal output. Those are good use cases for AI and machine learning. Results don't need to be logical yes or no and can be a probability. So there's a 60% chance this is a letter or a legal letter. We'll come to some of that. But those are more cases where we are looking at the results and not just yes or no, or other decision and rules engine like scenarios that we typically come across. The third one is around human supervision and exception processing is part of the workflow. Generally, when the accuracy of these models are not as accurate, and accuracy builds over time, and also the fact that some of these you will get exceptions, you will get issues that need to be handled, the false positives, false negatives, and sometimes sometimes there's not enough information for things. So those are things where human supervision is part of the workflow. So you have to make sure that that is handled and it's not a completely automated process. And fourth one is, there are scenarios where there are completely automated workflows, but it's basically case by case on how we handle. But on a broad spectrum of things, this is what we think is a good idea. Uh, the other one is false positives and false negatives can be handled in the process. So it's not just that if something got misclassified, that's the end of it, or misunderstood or misextracted, then it should be, it shouldn't be the end of it. Um, the other thing is you should have sufficient amount of real data available. You should have production quality data, which is actually what your business is experiencing and not fake data. We discussed about this at length last time, but again, reiterating that. Other thing about training data is to make sure it is compliant with your policies. One of the things that we have seen, models learning, or one of the debates that are actually happening in the industry is, AI models are biased for certain conditions, certain genders, and certain racial races. So this is there is generally a bias that models build. But if you think about it, or if you look at it further details, we see that it's basically based on the data that it was used to train it. So our models are as good as what our human judgments are doing as of now. So it will all learn the good things as well as the bad things from that. So you need to understand that part. You need to make sure that the policies and regulations are complied with, and that models are explainable and testable. And the situation and the workflows are. So the other part is also that you need a data scientist to work with it, and not just an RPA developer or a program or application developer for this. The other part is also that some of these technologies should be reachable to you as of now. There's a lot of stuff happening in the world of AI. You may look at news, and you may look at breakthroughs, and you may look at published papers, and you may think of some of these technologies that are available and are very, very cool. Some of them have surpassed human error levels or human levels, so or human accuracy levels in some, sorry. So they have surpassed that. So that may look very enticing, but you also have to look at how much of that is actually reachable to you, and available in the as services, as APIs, as SDKs, as libraries, or you have the ability to use the technique or not. So it's essentially reachable. The technology has to be reachable. Just because there is a technology for it, it doesn't mean it actually can be implemented right away using that. So don't get carried away with what you hear or what you see. The other thing is, AI and machine learning, is this an absolutely a good use case for it? If there is no, straightforward, rules engine type approach or fuzzy logic type approach, that could be possible. I have seen people trying to use AI and machine learning as a shortcut for not actually having to write, the actual specifications and documentations around what needs to happen. Simple example was, instead of setting and writing down the condition and rules for a particular business process, the business wanted us to look at AI and machine learning and reverse engineer the logic, especially because they think that it was too complicated and AI and machine learning was too easy. But again, it turned out that AI and machine learning, when given data, it also didn't consider time, so it learned stuff from the back as well and things. So it's something that you have to be very cognizant about, that the data that you're providing and the use case that you're using is an apt one for AI and machine learning. So this is essentially what we'll come back to questions and answers, and I'm sure there'll be questions on this. Coming back to our first use case, I would ask Vachan to take up this first use case and talk about what exactly is happening here, and how this problem was solved using an AI engine.
Sure. Thanks, Ashish. Thanks everyone for joining. So this particular use case was for a certain biggest insurance provider. So the process was in such a way. I will give a description of the process. So they were getting hundreds of claim letters from the lawyers on behalf of the customers. So they were getting the particular claim letters, and the business used to process those claim letters and used to take certain information from the claim letters and update it to the claim systems. So if you look into this particular claims, so these are not electronic, they were sending papers. So what they were doing is they were taking the OCR of that particular, they were scanning those documents and updating it to the database. So they wanted to implement RPA, they wanted to automate the entire process. So the way we solved that particular problem was utilizing both RPA and the machine learning, because this particular problem requires some understanding of documents and all those things. Just the RPA cannot solve this particular problem. So we combined both the machine learning and the RPA. So the way it's structured here is, so whenever they get the claim bundles, they will scan that particular documents. Once we get the scanned documents and we take OCR of all those documents, claim consists of around like 50 to 60 pages, but there might be there will be a lot of supporting medical documents, bills, and all those things. But the business was interested in just one page, which is a claim letter, and they need to extract some of the information like what is the claim number, how much amount they are claiming, what is the response date, and all those things. So the way we model that particular problem is, once we get the entire OCR documents, we classify which one is the cover letter. Once we classify that cover letter, we use the extraction machine learning models to identify specific fields. Once we identify those particular fields, the RPA bots will take that particular model outputs and update it to the claim system. So this is the combination of RPA and AI utilized in this particular problem, and it gave them a good advantage of increasing the volume they were processing. At the same time, it did a lot of cost cuttings in order to implement that particular project end to end. Yeah.
Perfect. So I'll take up the next one. So this one is, we kind of talked about it last time, but this one was more implementation type example. This is where emails come in for support tickets, for support, sorry. And, some of the things that happen is initially somebody actually sits down and types that information out in a ticket, support ticket, and then it goes through its workflow and gets assigned and prioritized and stuff. What the use case over here was essentially that we should be able to automatically read some of these emails, identify what kind of a problem is being requested or being talked about, and then also how much priority we should be giving to this, and logging it into the system using RPA, but additionally using AI to extract the specific problem, the class of problem, and the priority in which this needs to be taken care of. Once those are identified, then you can identify who's the right person or the right queue for us to resolve this, and that is what it is then used to route to. So essentially, this reduced the time that it took for them to resolve tickets, and also it always kept a good understanding of what kind of tickets and what kind of load they are getting. And once you're getting hundred thousands of tickets or support emails a day, it gets pretty difficult for you to understand what's in the queue and what is not. And then this way you can identify very, very quickly what action needs to be taken, who needs to be resolved, where do you need to get staffed, where do you need to ramp up and ramp down. Those are the decisions that were being made possible on a very real time basis from this. In this example, there's a source of earlier emails and ticket information that's taken up, and we wrote a classifier for that. It was deployed as a service. Eventually, at runtime, there was an RPA bot that would actually pick it up, call this service, give it the emails content, and then in return it would get the problem and the priority and other metadata information, which then it used to then go proceed further and assign the ticket and resolve. So that's essentially what the support and auto assignment was. We come to again marketing lead optimization. Vachan, would you want to take this one up?
Sure. Thanks, Ashish. Yeah, so this is also a problem. This was also a project where we combined both RP and machine learning in a very good way. So this particular project was more related to marketing campaigns. So this was for a huge mortgage portfolio company. So what they were doing is they were getting marketing leads and for the refinancing offers, and they were getting the marketing leads from certain providers. And what they used to do is they were not optimizing, or they were not fact checking individual marketing leads, and they were sending the postal offers for refinancing for everyone based on certain business rules. And the problem was it was getting huge volume and the lowest response rates. And the because the volume was very high, they used to spend a lot of money in the postal costs in order to get a response rate of like 3 or 4%. So they were using RPA bots to run the upstream and the downstream processes for the marketing campaigns. So then we combine the AI here with the RPA. So now, in an optimized way, what the particular process is looking at, like, so we use the machine learning models to kind of optimize the marketing campaigns. So the way we did was we used the historical database to figure out um, who are who, which particular customer is highly going to respond. So we built the machine learning model to kind of predict who's more likely going to respond to a marketing campaign, and based on the historical data. So they had a huge leads database, and they also kind of log that particular responses. So now we know which of the parameters to look for during the marketing campaigns. So most of them are kind of a mortgage information, financial information, and the customer information, all those things. So we utilized all those particular parameters from the data, and we kind of build the models which can actually kind of predict who is most likely going to respond. So the output of the machine learning models are a kind of a probability, right? So the business is kind of a setting up a certain threshold. For example, let's say 85%, right? We set the threshold as 85%. So what the models will do is they will pick the candidates from the particular leads who are likely going to respond with the threshold maximum of 80%. So it kind of picks a certain subset of the customers who are likely going to respond, and it's going RPA bots are going to run the upstream and downstream processes. Uh, and by this way, we are optimizing that particular entire marketing campaign by reducing the volume they are sending. At the same time, it's now the response rates are very higher, and which leads to a huge savings in the postal costs.
Perfect. Thank you, Vachan. We'll move on to the next use case. And this is specifically for an example where we work for a commercial PNC insurance carrier. Essentially, what happens in this use case is that brokers and agents are sending requests for quotes. In their language they call that submissions. They are sent to the insurance carrier. So if a broker finds a client, let's say a restaurant that needs insurance, what it would do is understand the insurance requirement and then send a request to quote to multiple insurance carriers, and then select a good quote out of that, and essentially then go ahead and select that, right? So in this case, what's happening is they're sending it to multiple insurance companies, which essentially means for insurance companies, if they are quoting back, there is some chance that they will bind and eventually win the business, and some chance that they may not. Essentially because it's multiple insurance companies that they are competing against. But the effort that they take to actually sit down and underwrite and quote, assess the risk and quote, is pretty much the same for all of them, right? So that is a lot of effort. Underwriters are not a common skill right now. People don't aspire to be insurance underwriters anymore that much that they used to be a few years ago. So essentially, what this company wanted to do was have something in between that can decide what can be actually be quoted and what should not. Um, the model is pretty simple. The broker sends in a request. There are a few 10 important fields that there's an operator that looks at that email and types it out into our model. Once that model says, and then the model decides, and scores what the propensity that this is actually going to bind, and if that propensity is or that probability is good, based on the threshold and based on the current workload of underwriters, it could decide that and then come up with a decision whether to actually assign it to an underwriter, and secondly, which underwriter, and then or just maybe when the probability of you actually winning this business is too low, you would not even bother quoting it, and you would just send in a decline. And that's what the model gives out. The bot takes the input from the model, and then it basically understands what the model decided, and based on that, it would take one of the two. It would either send out a decline email to the broker and saying, sorry, we are not good, we decide not to quote for it, or assign it to the right underwriter to actually take a look and assess the risk and eventually send out a quote. So this is, they were able to save a lot of time, and were able to actually increase their efficiency, because now they are only looking at business that they have a higher probability of winning. So by simply introducing this, they were able to increase their top line. In our case, in this specific example that I recall, was close to about 30%, which is fairly good for that line of business. That's pretty much in terms of the use cases. We talked about the 4 use cases, and we talked about feasibility of use cases. We now really wanted to ask if you guys have any questions. We can go back to any of the slides if that is needed. We do have about 5 minutes to go through that. Megan, any questions?
Yes. Okay. The first one is, what are the tools available for implementing AI?
So we did talk about this in the last session where we talked about the implementation. Essentially, there are multiple types of tools. One, of course, is the AI tools that are built into RPA applications, RPA toolkits itself. For example, UiPath has AI Fabric and so forth. The other ones are, of course, there are enterprise tools like Data Robots, H2O, and some of the other ones. On the other side, people could use cloud-based services. Simple, Amazon, Google, and Microsoft all provide services. Microsoft has ML Studio, very good, and you could just hook into those services. Then on the other side, you also have simple services where you can actually host your output models and scripts as web services internally. Those are also options. So there are like multiple options you can choose. It depends on the use case and your enterprise and the actual requirements around it as well.
Next is, can you help us identify potential use cases for AI and understand feasibility?
Absolutely. We do this all the time. If you have a use case where you think there is a potential gap where there's a robot, there's a human judgment element where you're passing it to somebody and then picking it up again. These are good places where you could implement learning and can actually improve the efficiency of what is passed to that human in the loop and what is not, and eventually reduce that work. So yeah, we can actually go through some of these use cases, tell you what the technical feasibility of them are, what are the available technologies as of today that can actually help you with this, and then and look at give you a requirement of what you will need to train such a model. Okay.
Okay. Let me double check. Okay, that's the end of the questions for this session, actually.
Okay, perfect. I think we are done with these 3 sessions, three series of 3 sessions. So if you have any questions, feel free to email us. Feel free to let us know if there is any other content that you would like in this regard, and we'll be happy to add a 4th one if that helps. Okay, thank you everyone. Thank you so much for joining us.